Throughout history, inventions like the wheel and electricity changed everything. In 2024, Betavolt unveiled a battery that could be just as revolutionary. Smaller than a coin, this nuclear battery can generate power for 50 years. No recharging, no maintenance. Imagine pacemakers that never die, or phones that never need charging. But the real revolution could be in aviation. Aircraft no longer limited by fuel. The sky is no longer the limit. The future of flight starts here. Are we ready to answer the call? What exactly is this device? The Betavolt battery isn't a miniature nuclear reactor. There's no fission, no dangerous heat, no meltdown risk. Instead, it uses the slow, steady decay of nickel-63, a radioactive isotope. As nickel-63 decays, it releases beta particles, high-energy electrons. These electrons hit layers of diamond semiconductor, knocking loose more electrons and creating an electric current. No moving parts, no chemical reactions, just silent, solid-state power. The battery is modular like stacking power tiles. You can build it to fit almost any device, from sensors to larger machines. It's inherently stable, no chain reaction, no explosion risk. The beta particles are easily stopped by a thin shield, making the battery safe to handle. This is an entirely new spacecraft like the Voyager probes have used similar tech for decades. What's new is Betavolt's miniaturization. Smaller, safer, and potentially affordable. They've brought space-age power down to Earth. Now it can fit in your hand or inside the wing of an airplane. The implications are huge. A battery that lasts for decades could change everything from medical devices to aviation. Betavolt's innovation is about making this technology practical for everyday use. The atomic age of batteries has arrived. How would this power source change aircraft? Today's planes are built around fuel tanks, huge, heavy, and constantly changing weight. Replace that with a compact solid-state battery that never gets lighter or heavier. Designers could ditch massive tanks, making wings thinner, longer, or more efficient. Blended wing body designs, once impractical, could become the norm. Power could be distributed dozens of small electric motors along the wings, creating quiet, efficient lift. Distributed electric propulsion means more control, less noise, and greater efficiency. Aircraft could take off and land vertically, making urban air taxis practical. Current batteries limit range, but a nuclear battery erases that problem. Air taxis could run all day, transforming city travel. The sky could fill with quiet, efficient vehicles powered by atomic energy. Aircraft design would be freed from the constraints of fuel. The possibilities are endless. The future of flight could look nothing like today. The revolution goes beyond design. It changes how planes are built. Today's aircraft require complex fuel systems, tanks, pumps, and miles of plumbing. With nuclear batteries, manufacturing becomes more like assembling electronics. Plug-and-play battery modules replace intricate fuel lines. Fewer parts mean faster, more automated assembly lines. Lighter power systems allow for even lighter composite materials. Maintenance shifts from engines and fuel systems to simple electric checks. The supply chain transforms. No more global fuel logistics, just battery modules delivered once. Manufacturing becomes more resilient and predictable. The overhaul industry shrinks as electric motors and batteries need less upkeep. The entire ecosystem, from factory to airport, becomes simpler and more efficient. The atomic age could make building and maintaining aircraft faster and cheaper. The way we make planes is about to change forever. The future factory is here. Once airborne, these aircraft would operate in ways we've never seen. Flight endurance would be limited only by crew and mechanical parts, not fuel. Non-stop flights between any two cities could become routine. Cargo drones could circle the globe for weeks, never landing for fuel. Airports would be transformed. No refueling, faster turnarounds, cleaner and quieter operations. Research planes could stay aloft for months, gathering climate data. Disaster relief drones could provide communication for weeks after a crisis. The operational possibilities are vast. The sky is open for business, without limits. Safety is the first concern with anything nuclear. Betavolt's battery uses no fission, no chain reaction, and can't explode or melt down. Nickel-63 emits only weak beta particles, easily blocked by thin shielding. The battery is encased in tough, multi-layered protection, safe to handle even in a crash. Certification will be strict, impact, fire, and immersion tests far beyond today's standards. Each battery will be tracked from creation to recycling, ensuring no material is lost. At end of life, batteries are returned, recycled, and the radioactive material reused. Public trust will require transparency and rigorous safety at every step. The design is about making nuclear power as safe as possible. The atomic heart of tomorrow's aircraft will be the most protected part on board. Safety isn't optional, it's built in from the start. The future of flight depends on it. For airlines, cost is everything. Nuclear-powered planes will be expensive to buy, but the savings are massive. No fuel costs for 50 years, removing the biggest variable in airline budgets. Maintenance drops as electric systems replace complex engines. Faster turnarounds mean more flights per day. Airlines could offer new routes, stable ticket prices, and consistent profits. Quiet operation opens up more airports and schedules. The first airlines to adopt this tech could dominate the skies. The investment pays off for decades. Private aviation stands to gain even more. Nuclear batteries mean unlimited range, fly anywhere, anytime, no refueling stops. Quiet, emission-free flights open up airports with noise restrictions. Lower operating costs make private jets more accessible. Personal air vehicles, small vertical takeoff craft become practical. The dream of flying from your driveway to your destination could become reality. Private aviation could move from luxury to everyday convenience. New markets and new buyers emerge. The skies could be democratized for all. The future of personal flight is within reach. By 2075, aviation could be split into two eras: fossil fuel and atomic. Quiet, electric aircraft dominate short-haul and urban travel. Blended wing, high-speed planes make global trips routine. Air taxis and personal vehicles erase traffic jams. The same batteries could power deep space missions and lunar bases. The journey from lab bench to Mars colony starts with this battery. The future depends on innovation, safety, and public trust. Betavolt's battery is a seed for a new era: clean, abundant, and long-lasting energy. We're on the verge of unshackling ourselves from the ground. The atomic age of flight is about to take off.